there, and thank you for your question. So in this question we are given the reaction of silver sulfide decomposes into silver and sulfur ions, and that we are given an equilibrium constant of 2.4 times 10 to the negative 4, and we're also given the concentration of our sulfur, which is 0.0023 moles per liter, and we're trying to find what our silver ion is going to be, what its concentration is at equilibrium. So I always like to start out with what we are given, and we are given the concentration of our sulfur, which is right there, is equal to 0.0023 moles per liter. And we're also given our equilibrium constant is going to be 2.4 times 10 to the negative 4, and I like to rewrite that in its decimal form. So when I do that, I'm going to move the decimal place 4 spaces to the right, or 4 decimal places to the right, and that's going to give me 0.00024. So 1, 2, 3, 4. Sorry, to the left, because we're getting a smaller number whenever we have an exponent that is a negative. And what I'm trying to find is the concentration of silver at equilibrium in moles per liter. So that's what I'm trying to find. I'm going to use the formula where I have the equilibrium constant is equal to the concentration of my products over the concentration of my reactants. So my first thing I need to do is identify which are my products and which are my reactants. So silver sulfide is going to be my reactant, and my products are the silver and the sulfur ions. So those are my products. So my products on the top are going to be the concentration of the silver ions times the concentration of my sulfur ions, but my silver ion has a coefficient in front of it of 2, so that means I'm going to raise this concentration to the power of 2. So remember, whenever you're rewriting these equilibrium constant equations, that if there is a coefficient in front of a product or a reactant, that's what you're going to raise it to, raise the power to that coefficient number. Now my reactant in this case is my silver sulfide, but you can see that it's in solid, it's a pure solid form, so we don't include pure liquids or pure solids in our equilibrium constant equation because they always remain constant, so we can just put a 1 there. And that is the equation that we're going to use. So this might have been your stumbling block. If you included the silver sulfide, you might have wondered, how am I going to solve for 2 unknowns? But this definitely is a 1 in the equation because we don't include the pure solid. Now what I can do is I can fill in the numbers that I have. I know that my equilibrium constant is 0.00024, and then I'm looking for my silver concentration, so that's my unknown, and my sulfur concentration is 0.0023, like that. And then I'm going to use algebra to solve for this. I'm going to first bring the 0.0023 over to the other side. I'm multiplying here, so the opposite of multiplying is dividing. That cancels that side out, and whatever I do to one side, I need to do to my other side. And then that's going to leave me with my silver concentration on this side, and 0.0024 divided by 0.0023 gives me 0.1043. Now I just need to get rid of the power of 2, and to do that, the opposite of raising something to the power is square rooting it when it's a power of 2. So I'm going to square root that side. That gets rid of my 2. And whatever I do to one side, I have to do to the other. So that's going to leave me with my concentration is equal to the square root of 0.1043. And the answer to that is 0.32 moles per liter. And that is the answer to this question that you're asking. So I hope that clarified where you might have been going wrong with your answer. And if you have any questions about this, please leave it in the comment thread. Thanks so much. Bye for now.